remember. All right, on 20, they told you that theta was 19 pi over 12. They told you the radius was 12. Now, this is the theta for B. When you get to C, we're asking for the arc length of the entire circle, which is the biggest arc you can find. And when you're working with the entire circle, theta is whole circle, 2 pi. 6 and a little more is 2 pi. And then when you're doing the area of the whole circle, theta is 2 pi. So that need to make a qualification on our thetas for C and D. So because we're looking for the area of a sector on B, I expect you to write A equals 1/2 theta r squared. What is our theta? 19 pi over 2, 12, just kidding, times my radius squared. And when you do that, that's going to be 19 pi over 24 times 144. And that's simplified to 114 pi. Part C, we're looking for the length of the whole entire circle, which means we're on the arc length formula, not this area formula. That's theta times r. What is the theta on a whole circle? 2 pi. What's my r? 12. So this is 24 pi. On D, we're looking for the area of the whole circle. So instead of just a part of it, we're going to do the sector is going to be the whole thing. What is the angle measure of a whole circle? What's theta? Theta? 2 pi, and my radius gets squared, so that's going to be 12 squared. The 2 simplify, so that's going to be 144 pi. That's a whole problem. Okay? So these two problems required two formulas. One of them was your area of a sector formula. The other was your arc length formula. Now I want to show you something that amazed me because trig was always kept separate from geometry as far as our radian measure was concerned. So if I take my arc length of theta times r, what is a full circle in theta terms? Have you ever seen the formula 2 pi r? In middle school, that was your circumference formula. Now, if you prefer that, that's fine. But that means you have to remember arc length for not a whole circle, and this for a whole circle, which means you have to remember two formulas. Let's go to the area of a sector. The area of a sector is 1/2 theta times r squared. What is the area, or the theta, the angle measure of a whole circle? 2 pi. So if we look at this, the 2 simplify. Have you ever seen pi r squared?
Yes.
Was that not the area of a circle?
Yes, it was.
Okay, so you're more than welcome to use that, but my point here being is that if you choose to use these, you have to know this formula for part of a circle. You need this for the distance around an entire circle. You need this for part of a circle, and you need this for a whole circle. I'm advocating that all you really need to know is this formula and this formula, and you have everything. And I have found in my experience, the less I have to remember, the better it is. If you have your key geometry term spreadsheet, some of you printed that. I asked all of you to print that. I would like to add some things to that. I started it out for you all. Madison has found hers. It is online. If we go here, darn. Did it go away? It is under worksheets and it's called key geometry terms. I'll look for it later, but it's there. All right. So in the first column, I would like you to put arc length. okay, in the first column. In the second column, I want to see L is equal to theta times R. And in the third column, you might want to write L is arc length. You might want to write theta is central angle in radians. Anybody find their spreadsheet so you can hold it up so others can see what it looks like? Yeah, that's the spreadsheet I'm talking about. Caitlin has hers, Madison has hers. Look at Madison, she's pulling it out. Hold it up high. Okay, it was a whole spreadsheet. Tara's got hers, all right? And then I write R is equal to radius. Okay, then I would write area of a sector in the left column. I would write this formula, A equals 1/2 theta R squared. And the definitions are the same for this. And then I'd also make a notation that the radian measure of a whole circle, What's the radian measure of a whole circle? 2 pi. That's important so that you can use arc length for circumference, area of a sector for a whole circle, if you know this. All right. And in order to use these formulas, all right, in order to use these two formulas, the angle must be in radian measure. Must be in radian measure. Central angle in radians. Okay, this is just an emphasis. All right, we're going to revisit what you did last night tomorrow after I teach what we have to do today. How many people are taking chemistry right now? Raise your hands. I want to see how many. Okay, this is a lot of people in the class. For those of you who are not taking chemistry, this is going to improve your skills or give you a skill prior to entering chemistry that you're going to need in chemistry, which will make chemistry easier. This is called dimensional analysis. You do it. It's a really fancy word, but you do it all the time. And you do about 4 strings of it in chemistry. Yes. Yes. So this, yes, you do. All right, here we go. So I need you to take these notes. No, I'm using this circle for a different reason now. Okay. All right, so Madison has asked me to ask you to pass your homework to the center. Yes, it's a continuation of yesterday's notes. Now, it's still the radian measure. By the way, today EOC is number 7. Number 7. All right, 0 radians. This is, if you're here, this is 0 radians or 0 degrees. Now, if I travel all the way around the circle, it's also 360 degrees or 2 pi radians, correct?
Yes.
Okay, I kind of abbreviated that. Now, what is it if I travel from here to here? Okay, that's 180 degrees or 1 pi radians. Excellent. Excellent. All right. And that is the key. This is where we get our conversion factor. We know that pi radians is the same as 180 degrees. Now I'm going to kind of do a sidebar, kind of get off our path here, but you've played with this before. If I have 1 foot, it is equal to 12 inches. And when we do conversions, because that's what we're doing today, is we're conversions. We're changing from degrees to radians, radians to degrees. When we do conversions, we write what we call a conversion ratio. We either write it as 1 foot over 12 inches, or we write 12 inches over 1 foot. These are equal. These are equal because a foot is a ruler, 12 inches is a ruler, so we have a ruler over a ruler. That is equivalent to 1. Both of these are equivalent to 1. So I can take this conversion factor and I can write two different ratios. And the key is choosing how you set up the fraction. Okay? Now, I just want to show you, I want to show you this. Could we have done 2 pi radians equals 360 degrees? Could we have done that? Okay. However, we choose to use the green here, and this is why. If I were to put 2 pi radians over 360 degrees, do you agree that this reduces, whoa, hello? I don't have a student. I think they wrote, oh, that's 20, this is 22.
Oh, I'm sorry.
That's okay. So this is 2 pi over 360 degrees, which reduces to pi over what? 180 degrees. And if I were to do 360 degrees over 2 pi radians, that reduces to 180 degrees over what? 1 pi. Remember, this is in radians. Okay, 3.14 does not equal 180. It's pi radians. It's a key piece to understand. So you see, when I take this and I do pi over 180 or 180 over pi, the 360s reduce to it. So we're using this one because it's the simplest form. So basically what we've gone over here is what's on my next slide. On the next slide, it's written out in a little bit more. We're using more words. So we're going to convert from radians to degrees and vice versa. And again, the simplest conversion ratio is 180 degrees equals pi radians.
What's the difference between pi and pi radians?
Pi is the number 3.14. Pi radians means, remember on your investigation, if I were to take this radius and I were to put it along the circle, this angle is a radian. So 3 and a little more of those is equal to 180 degrees. So a radian is basically an opening of an angle. Its opening is based on a single radius. So to say pi is equal to 180, it's wrong, but pi radians. Now, do they usually write radians all the time? They put, and so we're going to remember that that's radians, but I'm going to write it for a while. Bless you.
You're going to teach both ways, like pi r squared and this way?
We're doing conversions. The pi r squared does not involve conversions.
That's area, right?
Yes.
Oh, when are we doing area?
Okay, we did area, but we did it with a equals 1/2 theta r squared. Let me see if I talked about that. Here.
Oh, we never actually did it.
Okay, so I went over, whoa. Okay, I did talk about the fact that our arc length can be transformed into circumference. If you remember, oh, I don't want the eraser. If you remember that theta is 2 pi r. And I also showed everybody that when I substitute the full circle angle into my area of a sector, I get what you used to think of as the area formula for a circle. So you see, what you didn't know is that these two formulas were in radian measure. You just didn't know that. It is your choice whether you remember 4 formulas or whether you remember 2. As far as my teaching, I'm going to work with 2 only. And I'm going to remember that theta in a full circle is 2 pi. And the reason why I'm doing that is that cuts in half the number of formulas you have to remember. By the end of this school year, there's going to be a lot of formulas you're going to need to know. They're going to give you the 3 trig. They're going to give you a generic volume, a generic cone, pyramid volume. They're going to give you a sphere, and they're going to give you y equals mx plus b in point slope form. That's it.
So they give us the simplest formula.
Yes, but all your two-dimensional area formulas you need to know. All right, so again, this was talked about on the page before. This conversion ratio can be written as 180 degrees over pi radians, or it can be written as pi radians, just like we did feet and inches, over 180 degrees. And you have to make the decision which one you use, and I'm going to explain in a minute how you make that decision. And for my chemistry kids, you know this. For my non-chemistry kids, this is where I'm going to put you ahead for next year. So our first objective is to convert from degrees to radians. So notice I have 120 degrees. So the first thing you're going to need to do is you're going to have to write these degrees as a fraction. So if I have 120 degrees with no denominator, what's the denominator understood to be? It's over 1. For example, if I have the number 4, it's understood to be that's 4 over 1, because 4 divided by 1 is 4. If I have 20, it's understood that that denominator is 1. All right. Yes. So now we have to choose. Do I do this one, or A, or do I use B? And this is how you make a decision. You're going to use the conversion ratio, making sure that the degrees is on the bottom, and this is why. That means 180 degrees is on the bottom. The reason why we want to do that is because we need to make sure that the degrees in the numerator simplify with the degrees in the denominator, and the only way that happens is for the degrees to be in the numerator and denominator. If degrees are in the numerator, degrees times degrees is degrees squared, and that doesn't make sense.
That's what you just showed us above, because it's the same thing, right? Yeah.
So, right. So this is going to be pi radians. So now what happens here is that these degrees cancel. And now what we're in is we're in radians. So this is going to be 120 pi over 180. And that's no longer in degrees, it is now in radians. This is not an acceptable answer because the EOC exam is not going to give you these multiple choice answers or multiple select answers or whatever they're going to do unsimplified. So what divides 120 and what divides 180? All right. I can write this as 120 over 80 with a pi in the middle. That's the same thing as 120 pi over 180. Same thing. Oh, except either one. What is not the same is if you put pi in the denominator. This is why this is the same. This is pi over 1. So numerator times numerator, denominator times denominator puts it that way. All right, so what divides 120 and 180? 60. 60 goes into 120 2 times. It goes into 180. So that is 2 pi over 3 radians. So we have successfully changed 120 degrees into radian measure. That's 2 pi over 3.
That's chemistry.
That's chemistry. But you won't be using pi and radians. You'll be using centimeters and millimeters and feet per. It's okay. Nathan, it's not harder than this. It's the same process, except you might have to do, see how I have one conversion factor? You might have 4 of them strung along. Because you have to do so many, yeah. All right. Okay, I'm just talking about simple conversions. I'm not going into that sort. All right. We need to come back to whole class? So let's do another one. This is 72 degrees. So I want to convert to radian measure. The first thing we do is we put that over 1. Then, because degrees is on top, means degrees must be on the bottom. So notice, when I go to write my conversion factor, I notice degrees are on top. That means degrees are on the bottom. And what did I write first? My denominator. So that means that if my 180 is on the bottom, pi must be on the top. Pardon? Stephanie, what was your question?
Do we have to write radian?
Oh, shh. The question is, why wouldn't we do 72 degrees and put 360 degrees on the bottom? You can, but then you have to put 2 pi radians on top, and that's just more, gets you bigger numbers and more simplifying. Pi over 180 is the same thing as 2 pi over 360. Yes, sir. Because when I go to my next piece, you need to see it. Pardon? Theta represents the angle. Radians represent its measure. All right, so at this point, you're going to have 72 pi over 180, and what divides 72 and 180? 9. Yes. 9 goes into 72 8 times. 9 goes into 180 20 times. I say this reduces more. 2 goes into 8. 2. 4 goes into 8 2 times. 4 goes into 25 times. So that's 2 pi over 5 radians.
Do we have to write radians?
You have to write radians? No, but I'm emphasizing that because we're going to need it on the next piece.
Which one are we doing next?
We're going to do 108 next. Yes, this is all your homework. All right. So, all right, that's why the notes are going to be online. All right, we're going to go to here. We're going to go to class 2, maybe.
I want to be the recorder.
No, I've never been chosen by recorder.
Well, nobody cares.
Neither have I.
Aaron, are you willing to record?
No.
If you don't want it, I'll call someone else. Okay, if you'll get out a blank sheet of paper to do it with, I'd appreciate it.
Wait, so we're doing 108?
Okay, we're doing 108. So what's the first thing? Aaron, you just got a homework pass.
Oh my goodness.
Aaron, what's the first thing I have to do? Put it over 1. That prepares for what we need to do next. So next we are going to do what? Lizzie?
Oh god.
Where? 180 on the bottom because it's degrees. Degrees are on the top. We have to simplify them. So what's on the top? Pi. Okay, we don't, pi r is like a variable. So you either put pi radians. You can't, r is not an abbreviation for radians. We don't have an abbreviation for radians, sorry. All right. So at this point from here,
So it's always going to be 108 down the bottom?
no. Because when I go from radians to degrees, it's different. Again, how do we choose?
These kind of problems though, right?
How do we choose? Because degrees on top, degrees has to be on the bottom.
Yeah, I get that. But
Good.
why is it always 108?
Because our conversion factor is pi equals 180.
Okay, so that was the question. It's
Okay.
always going to be 180.
The pi and the 180 will always be working together.
Okay.
Yes. Now, that's not pi, that's pi radians, because 3.14 is not equal to 180 degrees. As soon as we put the unit on, it's equal. All right, who did I? Brittany, I just chose you. Brittany, what do I do from here? 108 pi over 180. I'm going to leave radians off until this is simplified. I need to know what is going to divide 108 and 180. That goes to Bryce. If we take 9 into 108, that's going to go
12 over 20.
12 over 20. And that's, well, that was a whole lot quicker than we did first period. And then that's going to be radians. We did 2, and then we did 3.
Good job, right?
All right. One more time. Miriam, you pick the problem. Do you want to do 240, 132, or 320? Okay, we're doing 132. All right. So, Bryce, what's the first step? 132 over 1. That gets us started. All right. So now, how do I set up my fraction, Brian? Because it's degrees, and we want degrees to cancel with degrees. What's on top? pi radians. All right, so after this, what are we going to do? Albert? So we're going to have 132 pi over 180. And I'm going to leave off the radians till the end so that we can simplify. Eric? No. All right, Caitlin, what are we going to do? Divide by 2. Divide by 2. So this is going to be 60. Is that 66? Over 90? Is it 61?
No, that's just kidding.
Okay, and now I think that simplifies more. All right, we're going to, let's see. Stephanie, what are we going to do next? Stephanie, what number? 3. So we're going to reduce this by 3. We're going to reduce this by 3. So we end up with 22 over 30. And?
Pi radians.
Well, that goes more. So what, Ethan, what do we do next? 15 pi radians. Now that is finished. Yes, you actually 3 times 2. What do we do? That's 6. 12. 12 divided both of those. Okay. If you did not know that, we got there without knowing that. All right. Now, the next thing we're going to do, our next objectives is to convert from radians to degrees. This is all conversions. So their homework is conversions. You have to do it both ways. So, listen, converting from radians to degrees. All right, this is radians to degrees. Do you see we already have a fraction? We already have a fraction. You do not have to rewrite. You do not have to write this over 1 because it's already a fraction. So we're going to take our 3 pi over 4. But what I do want you to do is I want you to write it with its units. So write the radian measure with its units, because that's going to be important. Bless you. So now, we have to make a decision as to how are we going to write our conversion. So now the conversion ratio is going to make sure the radians are on the bottom. Why? Because radians are on top, which means pi radians is on the bottom, and the 180 degrees is on the top. And you need the degree symbol with your 180. Yes?
Doesn't the pi radians cancel out there now?
All right, the purpose of writing pi radians on the bottom is so that the pi radians here cancels with the pi radians there. At that point, we are now out of radian measure. So we have 3/4 times 180 over 1. And from here, what are we going to do? Madison's not here. What are we going to do? Nate? Nate, what are we going to do?
Multiply, right?
So what is that going to be?
540 over 4.
All right, and how many times does 4 divide 540?
135.
That's degrees. So that's going to be 135 degrees. All right. So you are using this relationship differently than you did before. It's all about what you're given. All right. So radians is on the top. Do you need more time? Right. All right. So now let's look at this one. We've got 7, 6 pi. What's the first thing I should be doing for this? Hold on. I'm going to call on people. No. All right. So, Brittany, what's the first thing we do when we're in radian measure? we're going to write its units. Okay, first thing I want you to do is write its units, because that, if you get confused, this is going to help you get unconfused. All right, so now we have to set up our conversion factor. So Ricky, if pi radians is on top, what's on the bottom of this new fraction? What's got to be down here? Okay, this is radians. Is 180 radian or is it degree? That's degree. If radians is on top, what has to be on the bottom? The radians. And what number, 180 or pi, is associated with radians? Pi. So pi radians is on the bottom, what is on the top? 180 degrees. All right, so from here we see that the pi radians and these pi radians are gone. So we have 7/6 times 180 over 1. Now, bless you, I want to show you one way that you can simplify these fractions a little bit easier. You can multiply 7 times 180 and divide by 6, or you can see that 6 will divide 180 30 times. See, I'm working with smaller numbers to simplify. So this is going to be 210 degrees.
How did you get 210?
7 times 30.
What? Can we just do 180 times 7?
You may do 180 times 7 divided by 6. Maria,
Yes, he's right.
we have 5 pi over 18. What's the first step?
Should be 180
Nope,
over
the first step. I want to see its units. All right? Got to put the units, because these units will help you see what you need to do in this next step. Wendy, what am I going to do?
multiply 180 over pi radians.
So we're going to do 180 degrees on top, and that's only on top because radians is on top over here. So in order to make radians cancel, they must be in the denominator. So the pi radians and the pi radians are gone. We are now officially into degrees. We have to simplify our degrees. Madison, how do we do that? Right. Which is 50 degrees. Make sure you give me your unit. All right, we have time for one more. We'll see if we can get a homework pass. Brian, what's the first step? The units. Excellent. We've got to make sure we're aware that this is radians because you don't see it. All right, next step. What's next? Because I haven't taken. Trevor, what's next?
All right. So then you got to multiply by 180 over pi.
And why did you choose this? Why didn't you do pi over 180? Excellent. Pi radians is gone with pi radians. No. All right, Hale, what do we do now?
2 over 7 times 1 over.
And that's degrees, and that's going to be 360 degrees over, or 360 over 7 degrees. And I would do the division. Anybody, that's going to be
51.43.
43 degrees.
Wow.